Hello, Emma. Good morning. Emma, hope you can hear me.
Hello, ma'am.
Hello, Abraham. Good morning.
Good morning, ma'am.
Good morning. We will start a new chapter today in science. Okay. Natural resources chapter. Natural resources 1. Physical resources. Now, we see many things around us like plants, animals, birds, trees, mountains, soil, rivers, ponds, runnels or channels, sun, moon, and many other objects. All these items are received by nature. They are known as natural resources. Okay, so all of those resources which humans did not make, okay, which were already there, okay, as a part of nature, are known as natural resources. Okay, they are of two types. Natural resources are of two types: biological resources and physical resources. Okay, natural resources are of two types: biological resources and physical resources. Biological resources, physical resources. Now, as the name suggests, biological resources consists of all the living things. Okay, all the living things or living organisms. And physical resources contain non-living things. Okay, non-living things. Now, some examples if you want to see of biological resources. You have animals, birds, human beings. Okay, these are all biological resources. And if we talk about physical resources that are the non-living things, we have air, water, soil, wood, etc. They are known as physical resources. We will read about physical resources in this chapter. Okay, whereas biological resources are discussed in the next chapter. In this lesson, we will talk about physical resources. Always remember that biological resources and physical resources both are natural resources. Okay, both are part of natural resources. Means that humans did not make it, and it was already there as a part of nature. Okay, did we make soil, or did we make the water or wood? Okay, no. Trees were already there. Okay, wood was there, air, water was there, soil was there. Okay, physical resources. Okay, and living things also. Humans do not create living things such as animals and birds and all. They were also present biological resources. Okay, both part of natural resource. Now, what are natural resources? Our nature has two types of resources: physical resources like air, water, soil, sun, wood, mountain, etc., and biological resources like humans, birds, animals, insects, microorganisms, plants, trees, etc. But they are together called natural resources. Okay? When we say the term natural resources, it has both the things. What things? It has both biological and physical resources. These are useful to us in one form or the other, like air and water required for life, plants and trees for making food, sun for light and energy, birds, animals, and other microorganisms are useful in production of food. In this way, other organisms and physical objects are needed for many important things. Okay, so we will talk about the importance or the use of some of the physical resources. Okay, some of the physical natural resources. First one is air. Air is present everywhere, although we cannot see it, but it surrounds us. Let's understand this by an activity. Okay, this is taking a glass made up of glass pane. Place a folded paper by twisting in a glass. Now place this glass in a tub full of water upside down. What do you see? You'll find that the water has not gone inside the glass, and this is the cause why paper is not wet. Okay. Place this glass and water tub in a slanted position. What do you see? You will find bubbles coming out of the glass, and water is going inside the glass. What are these bubbles made up of? These bubbles are made by the air present in the glass. When we slanted or tilted the glass to fill water, air came out in form of bubbles, air bubbles, and then the empty glass got filled with water. Okay? And the second time, this time, when you tilted it and the air came out and the water went in, the paper will also become wet. We find that even if we do not see air yet, it is present around us. Every object, even if seen empty, has air in it. Okay? Has air in it because we cannot see air, but air occupies space. Okay? Now, elements of air, or what is the composition of air? What is air made up of? Air is a mixture of many gases. Okay? It is a mixture of many gases. The chief gases which are present in the air, now the main gases are oxygen, nitrogen, and carbon dioxide. Other than this, we have water vapor, dust particles, smoke, and some other gases. Okay. Now, oxygen, which is present in the air, is the life-sustaining gas. Animals or organisms living in water also use oxygen for breathing. We know that we inhale oxygen to breathe and exhale carbon dioxide. Okay, so oxygen is important for us to breathe. All organisms and plants use oxygen present in air for breathing and leave carbon dioxide. And those organisms which are in the water, they take oxygen which is dissolved in the water molecules. Okay, that they take and that they breathe. Now, so carbon dioxide, if we are all leaving out carbon dioxide, so carbon dioxide should be the largest in the air, but it is not so. Why? Because plants use carbon dioxide. Plants take in carbon dioxide and release oxygen. Okay, this we know reverse thing happens in plants. They take in um, carbon dioxide, carbon dioxide, and they release oxygen. Carbon dioxide from air and water and minerals from land in presence of sunlight to prepare food. Okay, so the plants they need CO2 from air and water and minerals from land in the presence of sunlight to prepare food. Okay. How water and minerals from land? They have roots inside the soil. Okay. They have roots inside the soil and they gather up the nutrients with the help of those roots which are present in the soil. Okay. Plants will gather the nutrients from there. Then they utilize the carbon dioxide and the presence of sunlight to prepare their food. This process is known as photosynthesis. This process releases oxygen. Okay. It releases oxygen which mixes in the air. This is how plants release oxygen. So this is the, you can say, estimated or approximate content of air. Okay. Oxygen 21%, nitrogen 78%, and carbon dioxide or other air is 1% in the atmosphere. Due to this activity by plants, gas balance is maintained. Okay, so because plants they release oxygen, okay, it's not that only carbon dioxide is there in a very high amount in the atmosphere, but no, plants balance it. Okay, they, they balance the level of oxygen and carbon dioxide, and it also helps in the nitrogen cycle. Okay, so it also balances the amount of nitrogen in the atmosphere. Okay, now due to this activity, the gas balance is maintained. We should plant more trees to keep the oxygen in required quantity. When we need more fresh air, more oxygen, we should plant more trees because trees and plants they release oxygen. Okay. Any doubt till now?
No, ma'am.
Emma? Emma, can you turn on your video? Turn on your video, Emma. Let's try out the fill in the blanks. We cannot breathe without. Abraham?
Yes, ma'am. Ma'am, I disagree with one of them statements.
In the fill in the blanks, Abraham.
No, ma'am. When you were talking, ma'am, I just researched about it just now. I asked Google what is the world's largest um oxygen
Yeah.
producer, ma'am, and it's not plants, ma'am.
World's
I had
largest.
thought about some algae. It's actually photoplankton. In all the world's oceans, photoplankton is generating the most of Earth's oxygen through photosynthesis.
Photoplankton is a type of algae, right?
Yes, ma'am.
And algae is a type of a category, okay, which is not like
No,
about
ma'am. They are saying plant more plants. So, ma'am, the
this.
better idea would to be is to have more photoplankton.
Okay. Is that only found in the oceans or on the land also?
Ma'am, I think photoplankton is only found in the ocean.
Okay. Now, when it is found in the ocean, Abraham, it increases the level of oxygen in the ocean through which the sea animals breathe.
No,
Okay.
ma'am, this is not for ma'am. This they gave it for land even, ma'am.
They give it for land even.
Ma'am, 70% of the oxygen we breathe comes from the ocean.
Okay. Mm-hmm. All right. So the name is photoplankton. Okay, Abraham. That is a good piece of information. Hmm. Okay. Okay, fill in the blanks. We cannot breathe without
Oxygen.
oxygen.
Ma'am, is there any other planet with a similar atmosphere to ours? Like it's oxygen rich?
You will have to check, Abraham. You'll have to find out. Okay. There are like our planet is having like it's oxygen rich. Okay, but some other planets they have more of the other gases present in the atmosphere. Okay, due to which it becomes hard for us to live on them. Okay, or which makes life impossible because they have all those other gases in huge quantities in their atmosphere. What gases and how much quantity in the atmosphere you'll have to look up and see. Okay. Dash is present in an empty utensil. Air is a dash of gases.
Ma'am, air is a type of gas.
Air is a mixture of gases.
Ma'am, I asked Google. Ma'am, it doesn't look like there is
Hmm.
there is no other known planet that is oxygen rich. They
Yeah,
are
that is
saying, but there may be oxygen rich planets that would have been there millions of years ago, but which is also not true because there's no proof.
mhm.
They said the
Yeah.
proof is oxygen is locked in like some places.
Mhm. True, Abraham. So we have not found out a planet till now which is so oxygen rich that can sustain life like Earth does. That is true. Ash present in air is a life giving gas.
Oxygen.
Ash help in maintaining the balance of gases in the air.
Humans and plants.
Basically, trees and plants.
Yes, ma'am. Ma'am, if the composition of air was to increase with oxygen, ma'am, would it be a problem?
If the composition of air, if the composition of oxygen in the air would increase, would that be a problem? I don't think so.
Ma'am, but then that means we'll have less nitrogen.
Yes, then we'll have less nitrogen. If there is a small change, a small, very small increase, then that is fine, but not very drastic increase. Okay? Not very drastic increase in the nitrogen
Talking about a
levels.
very drastic increase.
I think that would cause a problem with a lot of things.
Ma'am, what problem?
One is the nitrogen cycle will be disrupted. Okay, you'll have to study this in more detail, Abraham. Okay, if you want to know it in depth, you'll have to look it up in more detail. It would disrupt the balance of nitrogen in the atmosphere. It would disrupt the nitrogen cycle. Okay, and that's the like effect that it will cause in the atmosphere.
Okay, ma'am, thank you.
Utility of oxygen and carbon dioxide present in the air. Why is oxygen and carbon dioxide present in the air important? You must have seen igniting a stove or when coals are burnt in iron. When air is blown or fan is used, wood and coal start burning fast. Okay? Igniting a stove is something like this. Okay, something like this. If you've seen a fireplace kind of something where you blow and ignite the coals. Yes,
Ma'am, Google is saying that it will cause more fires
it will cause more fires.
and mass extinction. So we don't probably don't want a lot of oxygen.
Yes, we don't want a lot of oxygen.
And humans would start to have oxygen toxicity.
Say again, oxygen toxicity.
Yeah, humans and animals would suffer from oxygen toxicity, a condition where excess oxygen causes oxidative stress from free radicals, damaging structures and leading to cell dysfunction, organ damage, seizures, and death.
Okay.
And a lot of things would start to rust even.
Hmm. Yes, Abraham, true. Okay. So that is why we do not need a lot of oxygen. Now, when coals are burnt in iron, when air is blown or fan is used, wood and coals they start burning fast. This happens because oxygen present in air helps in the burning of fuel. This is also why it said that a lot of fires will start. Okay, a lot of fires will start because oxygen present in the air helps in burning of a fuel. Okay, burning of a material. The more the oxygen is supplied, the more fast the fuel gets burned. Other gases present in air, like carbon dioxide or other gases, do not help in burning, but oxygen it helps in burning. Okay, but they extinguish the fire. Other gases they do not help in burning, but we can use them to extinguish the fire. Okay, we have an activity. Fill a bottle with 1 cup of vinegar. Put some baking powder in a balloon and tie it on its mouth. As baking soda falls in vinegar, an activity takes place and the balloon starts blowing. Carbon dioxide is mixing, produced by baking soda and vinegar. Now remove the balloon, this blown balloon, and leave the filled gas on a lighted candle. What happened? The candle will stop burning. This explains that carbon dioxide is helpful in extinguishing the fire. Okay, in extinguishing the fire. This is a good experiment that you can try out. Okay, you in a bottle you take some vinegar. Okay, and then on top of it you put a balloon with baking soda in it. As the baking soda falls in the vinegar, carbon dioxide is produced and carbon dioxide fills in the balloon. Okay, now you take the balloon filled with carbon dioxide and put that air on the candle flame. The candle flame will be extinguished because carbon dioxide is used to extinguish fires. Extinguish fire. Carbon dioxide is used. Okay, and oxygen is used in burning. Oxygen is used or with the help of oxygen burning of fuels takes place. Burning of fuels. Okay, fire extinguishers use this activity to stop the fire. Whenever a fire starts, then the handle is pressed or placed upside down on the floor. This breaks the bottom of acid inside the fire extinguisher. This activity releases carbon dioxide by baking powder and the air blows out the fire. Okay, the carbon dioxide blows out the fire. So this same phenomena that we did with the bottle and balloon activity, we use it for we use it in the fire extinguishers to extinguish the fire. Okay, what starts the fire or what is an important component for a fire to start is oxygen. And what is the gas that extinguishes the fire? Carbon dioxide. Okay. In the previous chapters, when I was teaching you how to extinguish a fire, okay, I taught you that one method is like there are three methods basically. Okay. One is to remove the fuel. Okay. One is to remove the fire. One is to cut off the air supply. Okay. Removing the fuel is very hard. Okay. So we use the other two methods, that is removing the fire and cutting off the air supply, oxygen supply. Okay, because if oxygen is there, then the fire will increase only, right? So when a person catches fire,
Ma'am, you have to cut the fuel down, no, ma'am. And the
cut the
fire
fuel.
start increasing. Like if you
Hmm.
want to put off a fire and the fire is coming to the rainforest, we could like the fire is coming is in a forest. We could cut the cut part like make sure the fire doesn't spread or cut the fuel that the fire is going to spread to.
Yes, Abraham, that is true. Okay, that is true. But that may not work all the time. Okay, because three things are important, right? To start a fire, the fuel, oxygen, and what was the other thing?
Ma'am, fuel, oxygen, ma'am, and you forgot heat.
Heat. Okay, something to produce the fire with. Okay, and the oxygen and the fuel. So either you can cut off the fuel, okay, or you can cut off the oxygen supply. See, when a person gets burned, you wrap that in a blanket. You wrap them in a blanket and they are told to rub against the ground. Okay, why? That cuts off the supply of oxygen. Okay, the blanket cuts off the supply of oxygen and the fire goes out. Similarly, many things, if such as a gas cylinder, or if they just caught fire, you just uh, wrap it in a blanket and roll it on the ground like that, so it will.
Ma'am,
Yes.
ma'am, ma'am, I was thought something different.
Okay, what did you thought?
Ma'am, when we had a homeschooling co-op, we were taught to do the drop and roll method.
Drop and roll is also correct,
If you
Abraham.
get a fire, you drop and then you start to roll.
Yes,
Because
drop
ma'am,
and roll
whether
is
you have the
also.
time to wrap the person in a blanket.
Mm-hmm. No, that also works, Abraham, wrapping the person in the
Yeah,
blanket.
ma'am, but in case of a fire and the person's caught in fire, where will you have the time to wrap him in a blanket and then keep him down on the floor?
Mhm. Drop and roll is also a correct method. Okay, I think the other thing was like dust. Okay, that can put off the fire. Okay, so or like soil, dust, or
Yes, ma'am,
that
sand also works.
sand. Yes, sand works. Okay, so when this person like drops on the floor and rolls, okay, sand also helps in extinguishing the fire. Okay, that is true. Now, see, this is your question. Think if there were only oxygen in the air, what would happen? This would burn the fuel, but to stop it would have been impossible. Okay, it would cause burning, and to stop it would be very hard because we do not have carbon dioxide. Okay, extinguish we will not be able to do. So either it is cutting off the fuel that the fire is spreading to, or either we would have, if persons are there, then drop and roll method, blanket and everything, cutting off the oxygen supply.
Ma'am,
Okay,
we
but if
never put
yes,
water on an oil fire, right?
yes, yes, because of the difference of density between the water and the oil. Okay, The water will just settle beneath and then it will not put out the fire. Okay, because there is difference in the density of water and oil. Also, we do not put water in the fires which are caused by electricity,
And more grease fires. And
grease
because
fires.
electricity travels through water.
Yes, because electricity travels through water. We do not use that. Okay, in both these fires. But with wood and all, we can use water. Okay.
Yes, sir.
Okay,
Thank you.
we will stop here for today. 19.2.4, that is air pollution, we will start tomorrow. Okay. 5 minutes break for you, and then we will begin with maths class. Hello, Joshua. Good morning.
Hello, ma'am. Good morning, ma'am.
Hello. Okay. Ibrahim and Emma, hope you are back too.
Yes, ma'am.
Okay. Videos on, please, all of you. Please turn on your videos. Now we were doing the pairs of angles. Pairs of angles. We will finish this topic. Okay. And then only I will start construction with you. Okay. Let's first finish this topic of pairs of angles and then we will begin with construction. Okay. Now we saw one second, complementary angles, complementary we saw. Right. Now using compass, draw an angle of 19 point, angle 90 degree, draw angle POC. Okay. Two angles are known as supplementary. Next we have the next angle that we have is known as supplementary angles. Okay, the next pair is known as supplementary angles. I didn't do supplementary with you all, right?
No, ma'am.
Okay. Now, what happens is that sometimes two angles, their sum is equal to 180 degree. Okay, their sum is equal to 180 degree. When two angles, their sum is equal to 180 degree, they are known as supplementary angles. Okay, take a look at this angle. (60°), 120 degree. Okay, if you can see that one angle is 60, one angle is 120. When you add it, 120 plus 60, how much? 180 degrees. So you can say that these two angles are supplementary angles. Okay, write down the definition. Two angles are known as supplementary angles if sum of their measure is 180 degree. If the sum of their measure is 180 degree. Okay. Now if I give you some random angles, are you like able to tell me what will be the sum? Yeah. I'll give you some angles. You just tell me that what will be their sum. Okay. Or sorry, if they are supplementary angle or not. Okay. Okay, Joshua, tell me angle 70 degree and angle 60 degree. Tell me, are they supplementary angles or not?
No, ma'am.
Yeah. Okay. Angle 80 degree and angle 180 degree. Oh, sorry. Angle 100 degree. Emma, are they supplementary angle or not? Is 80 degree and 100 degree supplementary or not, Emma?
Ma'am, can you
Yes.
repeat? Your voice is breaking.
Angle 80 degree and 100 degree, are these two supplementary angles or not? Abraham, can you hear Emma? Joshua,
Yes, ma'am.
is 80 degree and 100 degree supplementary angle?
Yes, ma'am.
Yes.
Yeah, ma'am, now I'm here. Now it's okay.
Okay.
Ma'am, yeah, the 80 and 100 are correct. Supplementary angles.
Yes. Okay. Write this down. Have you written it?
Almost, ma'am. I need to make the diagram.
Okay, you can make the diagram.
Done, ma'am.
Okay. Aman Abraham written?
Yes, ma'am. Wait 1 minute, ma'am. Done, ma'am. I've copied it.
Okay. Okay. Now, if you want to construct an a supplementary angle, this is the method. Okay, you draw two lines. And measure this angle. Suppose it's coming to 40 degrees.
Ma'am, will we need a geometry box today?
Just your scale and protractor.
No, ma'am. No, ma'am. I know, ma'am, but I know the concept is supplementary. Ma'am, today you said you're going to do angle construction.
I'm not doing angle construction. Okay, it is actually there when in the part where you are like having supplementary angle, meaning is there how to also draw supplementary angles.
No, ma'am, like angle construction without the protractor.
Without the compass.
Okay.
Okay, protractor is there without the compass.
Okay, ma'am.
Okay, so you draw a like you make two lines. Okay, you can check whatever angle it is that you are getting. Suppose I'm getting 40 degree. Then I subtract from 180 40 degree. What I will get 140. Okay, I will do 180 minus 40. How much I will get? 140. Now place the protractor at this point. Okay. Extend this line. Okay. Extend this line. Place the protractor here on the center point. Okay. And then mark 180 degree on this side. Okay. Mark oh sorry 140 degree. You mark here. Okay. And that will be your angle 140 degree, and it will be give you a supplementary angle. Okay, it will give you a supplementary angle. Or you can just make 120 on one side, okay, and 60 on other side, supplementary angles using the protractor and scale. Okay. Basically, that is a measure. That is the way to do it. Okay. Okay. I'm clearing the screen. I think I'll teach you in a separate class this thing, all the construction things. Okay. Next is there's one more thing which is similar to supplementary angles. They are known as linear pair. Okay, they are known as linear pair, which are also equal to 180 degree and are made on a straight line. Okay, we make them on a straight line, and they are called linear pair. Okay, like this. I'll give you one definition for linear pair.
Ma'am, I have a question.
Yes.
190 degrees, how will that be? Like 90 degrees is straight. So will 190 degrees be straight the other way?
190 degrees will not be on a straight line, Joshua. Okay. 190 degree angle is not supplementary. Supplementary will always be 180 degree. 105 and 75, you add them, you will get 180. Okay, it's not 190, it is 180. Okay, it is a set of two adjacent angles.
Just a minute.
Write this down.
Ma'am, may I use the washroom?
Yes, Abraham, come back fast. Okay. They are also adjacent. Okay. Linear pair angles are adjacent means they have a common vertex and a common arm, and they are also equal to their sum is 180 degrees. So those angles are known as linear pair.
Done, ma'am.
Okay.
Done.
So the next angles are known as vertically opposite angles. Or VOA. Okay. VOA. That is your vertically opposite angles. Now these angles are formed by two lines that intersect each other or that cut each other. Okay, two lines that cut or intersect each other by that vertically opposite angles are formed. Okay, how I will show you. Take a look at this angle. Take a look at these lines. We have a line first, okay, like this, and then another line like this. Okay, let's just give them a name. This is AB. This point O, and this line, let's name it CD. Okay, CD. Now you can see that CD is cutting the line AB. Okay, CD is cutting the line AB. Basically, the rule is that the opposite angles are equal, okay, which are vertically opposite to each other. In this case, what are the opposite angles? Angle
D and no, sorry,
AOB and COB, that is this angle and this angle, okay. Then AOC and BOD, that is this angle and this angle, okay. These angles are known as vertically opposite angles. Okay, vertically opposite angles. Now we will define it. those angles which are vertically opposite to each other sharing the same vertex known as vertically opposite angles. Okay. They are known as vertically opposite angles, VOA. Okay. Put in a hash and write vertically. Put a star and write opposite angles are always equal.
Ma'am,
Abraham, say, voice is not coming. You are mute, Abraham.
suppose they give us angle COB, ma'am, and then they ask us to find angle AOD. Ma'am, do we have to write the proof also, ma'am, or can we just give the answer straight? Like the
You can, okay, suppose angle COB is, you can
45
say
degrees.
50 degree or 45 degree, okay? And you are asked what is angle AOD. So you can write angle AOD is equals to angle POC equals to 50 degree, okay? In the bracket, vertically
Opposite. And ma'am, if they give like a triangle, like a triangle bisector, ma'am, when we learn further, ma'am, is it okay if we use signs instead of writing? I can instead of writing vertically opposite angle, can I write vertically opposite and can I just put the angle sign?
vertically opposite angle sign.
Yes, ma'am.
It is better if you write angle the word Abraham, okay? Because angle sign is put like when you are denoting the actual angles, like angle AOD and angle BOC, okay? You can also write VOA. If you just write VOA now, like here, that I mentioned the definition, then also it is correct. VOA, vertically opposite angles. Okay? Okay. One activity for you. Okay, written everybody? Am I written?
Yes, ma'am.
Yes, ma'am.
We just give Yeah, ma'am.
Hmm.
Yes, ma'am. Done copying. Thank you.
Okay. Now, I'm making some angles. You tell me if it is vertically opposite or not. Okay. If it is vertically opposite or not. Take a look at this angle or this diagram. I'll give them names. What you have to tell me is that is angle AOD and BOC vertically opposite angles, and angle DOB and COA vertically opposite angle or not. Okay, what angles am I talking about, Joshua? One is this angle and this angle, this angle and this angle. Another one is this angle and this angle. I'm talking about. Okay, are this angle and this angle, that is AOD and BOC, vertically opposite, or
No,
is
they're not.
DOB COA vertically opposite? No and no. Why? Because both are not straight lines. Okay, vertically opposite angles are formed when both are straight lines. Only AB is straight. Okay, CD is like this and like this, not a straight line. But if you take a look at this diagram and tell me, name them A, B, C, D, O. So angle AOD and POC, oh sorry, POC and angle BOD and COA. Yes, this is also vertically opposite angle and this is also. Okay, this one and this one. This angle and this angle is equal and this angle and this angle is equal. Okay. Okay. Understood. So even when you have it like this also. So angles forming are this angle and this angle equal. Okay. I just name them 1, 2, 3, and 4. Angle 1 is equals to angle 2 and angle 3 is equals to angle 4. Why? Same reason. Angle 1 and 2 are vertically opposite to each other angle 3 and 4 are also vertically opposite to each other. Now, any doubt in vertically opposite angles?
No,
No,
ma'am.
ma'am.
No? Okay.
Ma'am, Abraham has one, I think.
Um, Now, your homework for today is in text questions 11.4. In text questions 11.4 is your homework. Okay, is your homework. Now, for the secondary level, we had set a pattern. Okay, we had set a pattern for the 10th class that I'm teaching. 2 term exams, 2 half-yearly exams, and 1 final exam.
Ma'am,
Yes, Abraham.
ma'am, no half-yearly test in the month of December.
We can keep it early in the month of December, before Christmas, early in the first week. Okay, so this was the pattern that I had set for the secondary paper. Okay, we can follow it. We can keep maybe 1 or 2 term exams, 1 half yearly and 1 final exam. Okay, or 2 half yearly and 1 final exam. Final exam will be in February.
Ma'am, can we not have the final exam, ma'am, in February?
We will have the final exam in February.
Ma'am, I have my NIOS main hall ticket exam in February.
Okay, so you can give in January before Feb, like when you have prepared all the, because same thing you have to prepare, na Abraham?
No, ma'am. Ma'am, I would not say it's the same, ma'am.
It's almost same. Okay, I would say it is 90% same thing. Okay, only 10% some topics may come. Even when I have set your Unit 2 exam for NIOS, it is the same thing. Everything is the same from what I have taught you from this book. Simple interest, time, distance, work, decimals and fractions, same thing that I have taught you. That is going to come in the paper. Okay. Maths paper is 90 to 95% the same thing. Okay. Science paper 90% same, 10% some things may come. Okay. Or 80% same is their science. 10 to 20% some things might come which are a little different. Okay. Half yearly final exam I will tell you about. Okay. But yes, 1 term exam I will take. When I will take it, I'll keep it in the end of October. Okay. In the end of October, 5 chapters around will be there in this paper. Okay. 5 chapters will be there. Okay. 5 chapters will be there in the term 1 exam. Okay. Term 2 exam, half yearly paper. I will be holding in November end. Okay. Half yearly paper I'll be keeping in November end. And final paper I will decide with Hardik sir and I'll tell you. Okay. When I'll be keeping final exam. Alright. Okay.
Okay, ma'am.
What Joshua can do is, Joshua, the chapters which I have taught that you attended class for. You can attempt the rest of the chapters, Joshua. You study them. If you have doubt, I'll clear it. Okay. So you can attempt the paper, Joshua. Okay. Even in the previous chapters, you can attempt the paper. Okay. Maybe I'll not give you marks, but I'll check. It will be a practice test for you. Okay.
Okay.
Okay. Understood, Abraham. Hope it's clear to you. Okay.
Yes.
Okay then. Then I'll see you all tomorrow. Have a good day. Bye.
Bye,
Tomorrow,
ma'am.
bring your geometry boxes. We will start with construction. Okay.
Ma'am, tomorrow I will not be able to join because tomorrow is like a sort of a resting day for us. We can't join today, tomorrow.
Okay. So Joshua, can you watch the lecture later? Tomorrow I will start construction, but I will record it. Live class is there now, so watch it later on. Okay.
Okay. Okay, ma'am. Thank you, ma'am.
Okay then. Bye.